Hi everyone, this is Introduction Functions Day 4 for the Algebra Extension lessons. So a function is a set of ordered pairs x, y such that no x values are repeated. So we've talked about how you determine a function when the input isn't repeated, when the x, so it's 1x, 2 has a unique y, okay? Each x has a unique y. And the new concept for today, these are domain and range, which are vocabulary words that if you keep going in mathematics, it's really strong algebra concept that goes into higher level mathematics, domain and range. So domain is the definitions all x coordinates in the function's ordered pair. If you're looking at points, you're going to have individual numbers, but sometimes it's a range of numbers. You can have a domain be from 0 all the way to 50 with all the real numbers in between. Okay, decimals, fractions, etc. in between. And the range is the y coordinates, the output. That is your range. Okay, so for example, if you have 0.012635, your domain are going to be 0, 2, and 3, okay? And your range is going to be 1, 6, and 5. That's domain and range right there. Pretty simple. And if you're looking at it graphically, domains are going to be your x values and the ranges are going to be your y values. The domain is a set of all values of independent variable and the x coordinate and the y. And the range is the set of values in the dependent variable and the y coordinate. So identify the domain and range of each situation, then determine if the situation represents a function. So the proper way to write this is using braces, the curly braces. So the domains would be your x values, which are 0, 2, and 4. And your range is your y values, 1, 3, and 5. And is this a function? Yes, it is. X's are not repeating. No repeating x's. No repeating x's. I'm going to go down to number 3 here, and then I'm going to pause and let you do 2 and 4, all right? So 3 here, the domain in 3 here is this, the x value of this is -1, -2, -3. This is 1, and this is 2. And the y value down here is -1, -2, -3, and 1. You don't need to write the -3 twice. It's -3. And is it a function? Yes, it is. No repeating x's. Okay, and you can always use that vertical line rule. When you draw a vertical line, is it going through more than one point? Nope, no situation here is more than one point. So these are both functions. Pause the video, do 2 and 4, and see if you get the same answers as me. All right, welcome back here. So for number 2, is it a function? Domain is 3, 4, range is 6, 2, 9, and you don't ever really write the points twice in the curly brackets, but when you look at them, you can extract that the 3 is repeating, so it's not a function. And for number 4, the domain is -1 and 4. The range is 3, -2, and 1. And it's not a function because the vertical line test fails right here. When you draw a vertical line, it's going through 2 points, so that it makes it not a function. So the domain and range of an algebraic functions are usually assumed to be the set of all real numbers. In some cases, however, the domain or range of a function may be a subset of the real numbers, because certain numbers would not make sense in a real-life problem situation. The number of shoes and n pairs of shoes can be expressed by the function s equals 2n. Are there any values that would not be reasonable to include in the domain or range of this function? Yes, negative number of shoes and pairs of shoes. So like So negative numbers wouldn't even happen in the domain or the range because you can't have a negative pair of shoes. The domains can be all whole numbers, okay? So you can't have decimals for this. The range are going to be all even numbers. You can't have 3 shoes because you're going in pairs. I mean, you can if you lose them, but using this equation, you can't have an odd number of shoes. Because it comes in pairs, you're always going to have even number of shoes. So this is what you want to think of. So your domain would be even whole positive whole numbers. Okay, and your range would be, no, this is not even. That's not, just positive whole numbers. And your range would be even positive whole numbers. There are a lot of ways to write this. I'm just kind of writing it like that. The domain of this function is a set of values you may choose for n, the independent variable. Would it be reasonable to have no? The variable n represents the number of pairs of shoes, so it must not be non-negative. The domain is a set of non-negative integers. Okay? And you can't have decimals. The range of this, that's why they're using the word integers. Okay? I just decided to write whole numbers. Okay? The range of this function is the set of values you will obtain for the dependent variable s. The number of shoes and pairs of shoes. Is it possible to have 5 as a value of s? No. We talked about we can't have odd. Since one pair of shoes has 2 shoes, so on. So it's like even positive numbers. Okay. 5. The following temperature data was collected during the last week in July. Determine the domain, range of the data and if it represents a functional relationship. So the domain is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And your range is 96, 97, 95, there's a 96 again, 98, 100, and I see a 98 again. And this is a functional relationship? Yes. Domain, there's no repeating domain. Dale kept track of the number of sacks he made each football game, determine the domain and range of the data, and if it represents a functional relationship. So domain, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the range is 6, 7, 5, 8, 12, 11, 10, 13, 14, 9. And functional relationship, yes. It's each individual game, no repeating domains. All right, I hope this gave you a good idea on the introduction of domain and range. Have a good one.